What is the difference between objects and systems? For your warm-up, you wrote your definition of an object and your definition of a system. Then we talked about whether in physics we could call a tennis ball an object or a system. Most of you started out by saying it was an object, but then we looked at it a little bit more closely. And we decided that sometimes we would have to look at a tennis ball as a system, and frequently we'd have to look at it as part of a system. Then we talked about a car. For this one, most of you guys started out thinking that the car was a system. So there's lots of moving parts, lots of things interacting, but mostly in physics, when we're talking about a car, we're going to be talking about the motion. So usually, actually, in physics, the car is going to be an object, but not always. So we'll have to be careful with the situation here too. Then we talked about whether there was more than one type of system. Some of you had learned about open and closed systems previously, but not everyone. So we kind of had to figure out what those meant. I asked you guys to work in groups and write rules to determine when something's an object or a system. And then how could you define what kind of a system it was? Now, I wanted these to be logical rules, so if-then statements, so you could apply them to just about any situation. Alright, so this is a really hard task. It's very situationally dependent whether something's a system or an object. And is it an open or a closed system? So there's no textbook that lays out any kind of logical rules that I've found. If you find one, let me know. So I wrote up these rules because sometimes there's still going to be some judgment calls. Alright, if there's no relevant internal structure, then it's an object. But if I have to look at the internal structure, then it's a system. And obviously, when there's more than one object interacting, it's got to be a system. So objects can interact within a system without changing the system. What I mean by that is that they can change position relative to each other without changing how you've defined your system. Obviously, things have changed, but if the ball falls towards the earth, and my system is the ball on the earth, my definition of the system hasn't changed, just the position of those two objects. Alright. In general, if energy can flow in or out of the system, it's an open system. Now, in a collision, we're generally going to call it a closed system because we're going to end up talking about momentum as well. So we'll see that when we get to energy and momentum in Unit 4. If the system interacts with another system or object, then it's an open system. And if the system does not interact with anything else, and no energy comes or goes, then it's definitely closed. Okay, so we will practice with these rules when we actually start solving problems. If you want to hear someone other than me explain it, hopefully this is a hot link in your video, but if not, here's the URL. So this is a different AP Physics teacher, and he talks for about 4.5 minutes. The first minute's about all you need, but feel free to watch it all. Okay, we practiced using the rules. So there's two ways we could answer this. If you had to just pick one, and it was multiple choice, alright, I would say that in this case, we'd call it a closed system because we want to talk about collision, so we're going to have to talk about momentum eventually. So I'd want it to be a closed system so I could talk about conservation of momentum. But you didn't know that yet, so it's okay. Now, the two cars are moving on a roadway, and there is friction. So there's two ways to explain that then. If we're going to go with this being a closed system, you could say that during the collision, they don't travel very far, right? And it doesn't take very long, so we're going to ignore friction. So you could go with A. Or you could say, well, I know that really that time is spread out a little bit, and they're still going to travel as they're stopping, so I'm going to pick B. So here, I personally think B is the best answer. So if you're just going to pick one, All right? All the interactions here are between the cars and the road. There are no further external interactions. Okay, here, Hansville is doing his annual vacuuming. He's pushing his vacuum cleaner across the living room carpet. Now, all of these, Hans, vacuum, and the carpet, are part of the system, because really one of those isn't going to be interacting without affecting the others. So the only question here really was if you picked D, something else. In this case, because if it's only an annual vacuuming, there's probably a lot of stuff on the floor. I'd say that maybe the mass of the vacuum is changing, and as we'll see later, that might affect how it moves. So we might have to consider that. In this class, we'd only ever do that conceptually, not ever mathematically. And your final one, if two gliders collide on a friction-free air track, so that's like an air hockey table, there's no friction with the surface, okay? This was a true-false that the two gliders are a closed system. So, in this case, I think the answer is true, because they're the only two things interacting. And it's a collision. So I want this to be defined as a closed system. Okay? So we will talk eventually about energy in a collision. Okay? I've said that a couple of times. And yes, it's released during a collision, and we'll talk about that and how we can keep that as within the definition of a closed system. So don't worry about that nuance at the moment. Okay, this was your exit ticket. Most classes got this one done in class. If not, this was your only homework. All right, please remember to turn it in tomorrow. All right, and so I wanted to add some closing remarks. So if you happen to be watching this, whether or not you were in class today, all right, I want to read to you. All right, so you'll have to listen. This is out of the College Board's book, my little Bible for AP Physics 1, okay? So this is from the same big idea number 1 that I talked about yesterday, okay? So here's what it says about objects and systems. This big idea collects the properties of matter into one area so that they can be employed in other big ideas. The universe contains fundamental particles with no internal structure, such as electrons, and systems built from fundamental particles, such as protons and neutrons. These further combine to form atoms, molecules, and macroscopic systems, all of which have internal structures. A system has various attributes or properties that determine how it behaves in different situations. When the properties of the system depend on the internal structure of the system, we must treat it as a system. In other cases, the properties of interest may not depend on the internal structure. In AP Physics, we call these objects. For example, the free fall motion of a ball can be understood without consideration of the internal structure of the ball. So in this case, the ball could be treated as an object. Objects and systems have properties that determine their interactions with other objects and systems. The choice of modeling something as an object or a system is a fundamental step in determining how to describe and analyze a physical situation. Okay, so that's all they say about it. Now, I want you guys to know that we don't have to get this right now. We're going to practice this, and we'll get better at it as we actually go through problems and start practicing whether things are objects or systems.